So I'll start off here with opening up Excel basically here. Come on, focus.
I tried to open Moodle and it's not getting what to do.
No. Why do you need to open Moodle?
Huh? I don't have a question.
No, I'm going to tell you the question. What you have here. Focus, please. I'm going to draw it for you. In question 1, they give you a circuit. Here's the circuit here. So you have your 2 batteries here. And then you have your ammeter here. And then you have your variable resistor. That means you can change the resistance. And then across the resistor, you have your voltmeter. Okay? No, please. Please, just focus here. So that's the diagram. Now, if you get to the formula book, and I'll write the formula down, okay? We did it last week, but if you're looking for it, it is on page 3, up the top. And the formula you use for this is V, voltage, equals the EMF of the battery minus the current times the internal resistance of the battery. Now we have other formulas like Ohm's law and stuff, but we're going to use this one. In fact, it's not important that you know this at this stage anyways. What's important first is that they give you a list of readings. So I'm going to just pop these. Actually, it'd be easier if somebody reads them to me and I can type them in. Do you have it there? Yeah, okay. So V, voltage, I, current. Okay, what's the voltages?
0.23.
Yep.
0.71.
Yep.
1.46. 1.86. 2.26. 2.43. 2.54.
And then the next one is current.
8.21, 7.09, 4.88, 3.71, 2.53, 2.03, 1.7.
Last one?
1.7.
Now, what's the first question? First question, easy peasy. What do you think it is? I mean, you don't have it in front of you. Plot a straight line. So, I'll just highlight it here. This is recording, isn't it? Yeah. Now, where's my graph one? Insert, chart, scatter, next. Okay, so this one here is voltage versus current, and the x-axis is the volt, V, and the unit is volts, and then the y-axis is current, I, and the unit is amps. And there you go. Don't really need this column B stuff here. So there you go, there's your graph. So how many marks for that? 4. Huh? Do I have it the wrong way?
Yeah.
Oh, flip. Do I? He wants V on the Y and I on the X. Ah. Thank you. Come on.
Impress me here.
I've just made it worse. I'll get it. I know.
Just close to it.
I know how I'll fix this. New tab. Alright. Sorry, so which is on the x-axis? So actually I think I should put this in. This is Sylvia now, hang on. She's looking for Saudi students. Sylvia. The numbers have increased, but none of them are Saudi. But my understanding is Lorraine took them from the last class down. Is that what happened, guys? Was Lorraine talking to everyone at the end of the last class?
Just a few community.
Yeah. Okay, will do. Okay. Now, let's try this again. Insert, chart, scatter, there we go. Next, next. V versus I. X-axis is the I, which is in amps. The Y-axis, which is V, which is in volts. Okay. Is that okay now?
Yeah.
Right, so that's 4 marks. The next part is to get the slope and intercept. So I'll do the insert trend lines, show equation. Can somebody, Brandon, can you just write this down, but just give me 3 significant figures, please. Don't you? Zoe, thank you. V equals minus 0.3396. Yeah. Plus 3.1178, would say. Okay, so now we actually have our first answer to write down. A part 1 was the graph, which I did, and A part 2, what is the slope?
Minus 0.3396.
Okay. Part 3 is used as to calculate the OR. Okay, now if you look here, here's the formula. So if you just compare it, whoops. Sorry, can you tell me what the formula was? V equals...
Minus...
Yeah, actually give me the C first, actually, be better.
3.1178.
Minus 0.3396 I. So in fact, if I just write this the other way around, you can see very, very clearly what each one must be. You can see that this here is like the C, and the OR is like this number. And he wants the resistance in the battery. So OR equals 0.3396. Is that right? No, actually it's not, because be careful. You have how many batteries here? 2. No, because they're in... Why are you so late?
I was just. Are you sounding?
Yeah, are you Saudi?
I was. Are you
Are
sounding?
you, come on, are you Saudi?
No.
No, so why are you late? What do you have to talk to Sylvia for?
Are you sounding? Are you?
No. You could be Saudi. You never know.
Your great grandfather.
Could be. He could be a secret Saudi billionaire.
Exactly.
Yeah. Treat him with some respect. Although he's not. Now, that's actually not the resistance, because that is the total resistance. So what, is this in series or parallel? What law do you need? Parallel. So in fact, you have this rule next. 1 over R plus 1 over R, that equals 1 over this. Do you understand?
Yeah.
So this will be 2 over R, so 2 times that equals R. Yes? Okay, so what is this? Oh, it'd be about 6, 8. Yeah. I mean, this is about 3, 4. So it's about 6, 8. If I just do 2 decimal places, yeah? Ohms. Right. Whoa. That was just 6 marks. That can't be right. Whoa. That was just 6 marks. That question on the board now is 6 marks. Dang. Can't believe that. 6 marks for that. So, how many marks have we got so far in this question now? 14. Is it? Yeah, 14. Alright. Calculate the power inside a single cell when the difference across the variable resistor is that as given by the table above. That he just wants the power in the resistor. So what's the formula for power? IV. So, whoops. Power equals. Hey, come on. What's the I here? 8.21. And what's the V?
0.3.
Okay, can you take out your calculator and tell me what this is? In fact, I might have the answer. Here. Oh wait, no. Wait, hold up. Sorry, my mistake. That voltage is across that table. I'm going to start confiscating things now. No, please wait. Okay. No, stop.
I'm not the teacher yet, I'm frustrated.
Look, that table there, okay, that's for this voltage, yeah, and this here. But what he says is calculate the power inside a single cell, that's inside this, when the potential difference across the variable resistor R is that. Okay? So I'm... Hey! Wait, hold up. Are you Saudi?
No.
So why are you so late?
I was printing this for you.
Oh, kind. Sit down. Okay. Confusing me. Right. So that current of 8.21. Look here, people. That 8.21, that's through this here, see it? But we're looking at the battery now, so what current should I use? I shouldn't use 8.21, what should I use? What should I use? Should I use 8.21? No, because the current splits here into 2. So what current do I use? Yeah, so first I have to divide by 2. Okay, so what's that? 4.105, thank you, yeah. Okay. And in fact, rather than using IV and worrying about the V, I'll use the other formula for power. Does anyone know the other one? I squared R. Very good. So that's 4.105 squared. Now what's the resistance here?
0.33. Oh, sorry. My bad.
What is it, the resistance here? Does he say, sorry? 0. Oh wait, no, we know the resistance. He's talking about one battery, isn't he? So the resistance going to be 0.68. Okay. What's that, please? Can you calculate?
11.46.
You sure?
11.46.
Okay. This is the formula for power, isn't it? I squared R, that's the other one, isn't it? Yeah? Let me just double check. Yeah, it is. Okay, and what's the unit here? Watts. This looks a little bit different to the marking scheme I have here, but I'm feeling confident in saying that it's just a typo, because in the marking scheme, instead of having I squared multiply or, they have I squared divide or. So they have all the numbers right. It's just a typo. Okay. Next part is suggest why using last part. Why using two cells in parallel might be of benefit compared to one cell. So what's the benefit of using two cells
Low voltage.
in parallel?
In parallel.
So the voltage is the same.
Current.
Yeah, it's to do with the current. Do you make the current? Yeah, go on.
Yeah, current is more easy.
More, less, big, small. Let's look at each one here. Here is my ammeter, and here is my ammeter here. Oh, sorry. And I can have my two batteries like this. Oh, wait, sorry, the other way. Too big. The question is really, let's get rid of this ammeter symbol here for a moment. What's the advantage of having the system power supply set up like this instead of like this? Well, first, I think the biggest advantage for me I can see is that the total resistance here, will it be bigger or smaller? Yeah, it'll be smaller here. So if you want to minimize the resistance in the battery, or the effect of the resistance in the battery, you should set it up like this, because the total resistance will be, let's calculate it, 1 over R plus 1 over R, that equals 1 over R. So that means 2 over R equals 1 over R. So what does R equal? R over 2. Now, if I do it like this, what's the total resistance? R plus R, which is 2R. So you have a choice. You can have resistance of R over 2 or 2R. Now, what's the problem when the resistance is too big? You get heat. So if you want less heat from the battery supply, you should use this one. Yeah. This becomes particularly important when the resistor behaves the battery or resistor behaves differently when the temperature increases. We know for some devices when the resistance goes up, when the temperature goes up, the resistance goes down, like a diode. But often when the temperature goes up, what happens to the resistance? It increases disproportionately. So the reason is we choose the parallel because it makes 4 times less resistance. So for example, if this was 10 ohms, then this setup would be 40 ohms. Big difference. Alright, and we stopped it there. So